Hello students, today we will see the next part of our lesson, and the lesson is the chemical change and chemical bond. Under this lesson we see in the different types of changes, okay, that changes why it takes place because of the some of the environmental condition the substance undergo oxidation and oxidation, and what happens we see the changes. Otherwise some activities are there, for example in baking soda if we are adding the lemon juice, we see the changes inside it. And some natural changes, that is a photosynthesis, digestion that we had seen, and man-made changes inside combustion of fuels, and that cleaning of Shahabadi tile with dilute hydrochloric acid, softening of hot water that we had seen already, and chemical bond inside. Here ionic bond we seen. And what is ionic bond? The ionic bond is what I told you, one substance donate the electrons and another substance is there. What happens? It receives the electron. One substance donate the electron and another substance receives the electron, and such a type of bond it is called as a ionic bond. And for that I told you that sodium, its atomic number is 11. So in first orbit 2 electrons will enter. If you see here it is the orbit and here 2 electrons are there, and second orbit 8 electrons are there, and at last 1 electron is present in outermost orbit. Okay, then in the chlorine inside, here in first orbit 2 electrons, its atomic number is 17. So first 2 electrons, here electron enter in the first orbit. In second orbit 8 electrons are there, and in the third orbit 7 electrons are present. So here in this, as I told you, its electronic configuration is 281 and here 287. So both sodium and chlorine, they are trying to be stable by obtaining the octet in its outermost orbit. So for that what is happening, the sodium, which is a metal, it donates one electron to whom? The chlorine. It donates one electron to the chlorine, and what happens? It acquires its octave. Now 28 is its electronic configuration, and the chlorine's electronic configuration is 288. Now both the substances, octave means outermost orbit octave is there, and that's why these elements are, the sodium and the chlorine, they become stable. And if you see here in the picture, you will notice that here 3 orbits are there, 1, 2 and 3. Here only 2 orbits are there. Outermost orbit is there. What happens? Because of donating one electron, only it remains the two only orbits. And after taking the one electron, just see the color of this electron, you will notice that chlorine also obtain its octave state. Now the next state is what happens? One more example of the ionic bond is given here, and inside it the chlorine, the electronic configuration, just now I told you that the atomic number is 17. Formation of magnesium chloride, MgCl2. Formation of magnesium chloride is shown in the picture. So here the chlorine, its atomic number is 7. Chlorine atomic number is 7. Magnesium's atomic number is how much? That is the 12. How much? 12. So here if you see the structure of the chlorine, here were first orbit inside. So here the magnesium, its atomic number is 12. So in first orbit 2 electrons, second orbit inside 8 electrons, and third orbit inside 2 electrons will enter. That is the electronic configuration. So whenever at the time of formation of the magnesium chloride, what happens? The magnesium has how many valence electrons? 2 valence electrons are present inside it. Okay, and chlorine, its valency is also 1. But chlorine requires 1 electron for the completion of outermost orbit, that is octave, and for this side also. So here what happens, when there is a electronic configuration is there, at that time when there is a bond formation is there, at that time what happens? The magnesium, 2 outermost electrons, what happens? It donates to the 2 chlorine. 1 electron it donates to this chlorine, and this electron is donating to the another chlorine. Now if you see the structure, that is magnesium, that is 2,8 chlorine, that is 288, and another chlorine is 288. From this, what happens? The electronic configuration means the octave of each magnesium and chloride is complete. Means all these magnesium and chloride, they are stable because the outermost orbit of these elements are complete. And in this way, the ionic bond is formed in between the magnesium and the chloride, and all of the octave obtain the octave, and this is the formation of ionic bond of magnesium chloride. It is taking place in between the magnesium and the two chlorine atoms, and here if you see, the magnesium donates the electron and chlorine receives the electron. There is no any kind of a bond in between them, so such a ionic bond is there. There is no sharing of electrons is there in between, and that's why this is called as a ionic bond. Now in the figure 13.4 shows that ionic compound magnesium chloride is formed from the element magnesium and the chloride. Okay, now show the formation of the following ionic compounds from the corresponding elements. So here it is using two methods, namely numerical diagrammatic representation of electronic configuration. So you have to do this. So first of all, here Kf means potassium fluoride. Atomic numbers are given here. Potassiums, here I will show you the by using the, so here Kf, the potassium atomic number is how much it is there? 19. So how is the electronic configuration of this? The first orbit, it contains how many electrons? 2. Second orbit 8. Third orbit, how much is the electrons are there in it? That is the 8, and here it is 1. Yes, so this is the electronic configuration of potassium. First orbit 2 electrons will enter, second 8, third 8, and then last orbit 1 electron is present in the outermost orbit. Now about the fluorine, then here first orbit 2 electrons, second orbit how many electrons will enter? 7. Then this is 2 plus 7 is equal to 9. Now here what I told you, 2, 8, 8 and the 1, and here it is 2 and 9. So 2 and 7. So here what happens? This electron, okay, is potassium donates this electron to the fluorine, and it contains now here how many electrons are there now? 2 and 8. Okay, this is the formation of the potassium fluoride in the, this is the electronic configuration. And if you have to show this into the diagrammatic form, this is the electronic configuration I shown you. The diagrammatic form also I will show you how it is there. So here this is the potassium, atomic number how much I told you? 19. And here it is what happens, F, that is the fluorine, and its atomic configuration, electronic configuration is 2, 7. And here it's a potassium's electronic configuration is potassium electronic configuration is 2, 8, 8 and the 1, and F 2 and 7. So when the electronic configuration takes place, at that time what happens? This is the first orbit, second orbit, third orbit, and this is the last fourth orbit. I am going to show you it roughly only. So first orbit inside how many electrons are there? 2 electrons are there. Second orbit how many electrons are there? 4, 5, 6, 7, 8. Third orbit also 8 electrons are there. 4, 5, 6, 7, 8. And last orbit how many electrons are there here? That is the 1 electron. Okay. Now the fluorines, the electronic configuration is in this way. First orbit, second orbit, second, 2 only orbits are there. So first orbit inside 2 electrons are there, and second orbit inside how many electrons are there? 7 electrons are there. So 1, 2, 3, 4, 5, 6, 7. Now what happens at the time of formation of the ionic bond, that potassium donates electron to the fluorine and it takes this electron, and due to this what happens, the outermost orbit of the potassium, what happens, it means only 3 orbits are remain here in this, and this is now they are stable. How? By donating 1 electron. What happens, the electronic configuration of potassium is 2, 8, 8 and that of the fluorine is 2 and 8. If you see, the both atomic means outermost orbit is complete now and they are stable. Okay. Now the next, it is the another one, it is told you that is calcium, that you can do, I think. Okay, so you have to do this today, that is calcium oxide. You have to complete this calcium oxides. Atomic numbers are given. Calcium atomic number is 20. I will tell you diagrammatic representation you do. I will show you only the electronic configuration, how it is donating electron. Due to atomic number is 20, first orbit 2 electrons, second orbit 8, 8 to the 16, 17, 18, and last orbit inside how many electrons are there? 2 electrons are there. Oxygen atomic number is 8, so first orbit 2 electrons, second orbit 6 electrons. To complete the octave of this oxygen, it takes 2 electrons from the calcium, and what happens, it completes its octave, that is, and here it is cancelled. The atomic electronic configuration of calcium is the 2, 8, 8 and that of the oxygen is 2, 8. Okay, so this is the electronic configuration in between the calcium oxide. The formation of ionic bond in between the calcium oxide is shown in this way. Okay, this is the electronic configuration I shown you. You have to just now how I shown you the diagrammatic representation, you have to complete and you have to send me on my personal number. So these kind of bonds are called as a ionic bonds. Understood? Now the next type is the otherwise what I will show you this calcium oxides, because covalent bond is there, it is very big part, and in half we will not finish. We will take it in details, we will take it that discussion on tomorrow only. So calcium oxides I will show you. Calcium atomic number is 20 and oxygen's atomic number is 8. So here calcium atomic number 20 and oxygen's atomic number is 8. As I told you, 2, 8, 8, 2. Okay, this is the electronic configuration of calcium, and oxygen's 2, 6. Now we have to draw the diagrammatic. So first orbit, second orbit, third orbit, and this is the fourth orbit. Okay, so here what happens, here first orbit inside how many 2 electrons are there, second orbit inside how many electrons are there, 8 electrons are there, third orbit also how many electrons are there, 8 electrons are there, and at last orbit how many 2 electrons are there. Just I will show you with the different color. So here it is the outermost orbit, these are the valence electron. Now this is the electronic configuration of the oxygen. So first orbit 2 electrons, second orbit 6 electrons, 1, 2, 3, 4, 5 and 6. So complete the octave, oxygen needs how many electrons? 2 more electrons it needs. So what happens in the formation of the ionic bond, what happens, the calcium donates these 2 electrons to the oxygen, and due to this electronic configuration is 2, 8, 8 and here it is 2, 8. Okay, so the outermost orbitals of oxygen is also complete and calcium is also complete, and due to this what happens, the calcium oxide CaO is formed. Okay, this is and in between the calcium oxide there is a which kind of bonding is there, ionic bond is there, and in ionic bond just now I told you before only, that is the calcium means one substance, means mostly the solids are the metals donate the electrons and non-metals receives the electron when it is the formation of the ionic bond at that time. So here calcium electronic configuration, calcium is a metal, it donates electron that I shown you, and oxygen it receives the electron I shown you. In this way the configuration is there. So all of you, today we are going to stop here only, and the covalent bond that we will study in our next lecture. Okay, thank you and have a good day. All of you read this, do this diagrammatic representation. All of you note down in your, means draw this in your notebook, because in exam figure, at the place of figure, these are also formation of ionic bond between the magnesium chloride, then otherwise the potassium fluoride, otherwise calcium oxide, sodium chloride. In these types of questions are coming in the exam. So this also you must able to draw this sketch of these substances. So today we are going to stop here only. Okay, thank you and have a good day.